Yeah, welcome to our presentation. We're going to talk today about thermography and process monitoring in harsh industrial environments. My name is Thorsten Schech. I'm head of marketing at Optris.
My name is Mike Lippe. I'm an international sales engineer at Optris.
Yeah, before we start, we would like to give you some information about the Optris GmbH. We are a manufacturer of non-contact temperature measurement devices. That means we are producing pyrometers, infrared cameras. We are doing also a lot of accessories, and this is the main topic for today, talk about the accessories. So how can our infrared thermography solutions survive in harsh industrial environments? And we do for all our products also software and apps. We are located in Berlin. We have about 115 employees, and we are producing around about 85 to 90,000 infrared thermometers and cameras per year. And yeah, we are proud. We have also offices in China and in the US, and we have a worldwide distribution network.
Yeah, let's have a look where we need or where we can find harsh industrial environments and why we need additional accessories for those harsh industrial environments. The first point is the ambient. So as you can see in the image, at the first image, that we have here a very hot environment, that we have here very hot ambient temperatures. We have here a furnace application, and we have positioned our camera in front of the furnace. So we have here a viewport where we look inside into the furnace. And you can imagine that we have here very, very high ambient temperatures, over 200 degrees C or over 300 degrees C, so that we have to cool down our system here. This is very important, and therefore we need here a solution. On the second image, you can see a forging application, and you can see a lot of dust and steam. And here it is also important that our optic is free from dust and from steam, that we have a free view on our object, and so that we clean the lens all the time. We have here also to have a solution. You can also see on the third and on the fourth image that we have sometimes very dusty ambient conditions. So our camera is full of dust, and here the IP rating is for sure important, and also that the camera is all the time clean. Fortunately, there are some pyrometers on the market, and yeah, we have here the CT series. These are small sensor heads. You can see here one of those small sensors. And these small sensor heads can withstand with a very high ambient temperature up to 180 degrees C. We have here also a special version, which is called CT Hot, which can be used in an ambient temperature up to 250 degrees C. And also for our ratio pyrometers, we have here ambient conditions where we can use the fibers up to 315 degrees C, and also the sensor head can used up to 315 degrees C. Yeah, how can we protect the imagers and the thermal cameras? First, the IP rating is very important. Here we have an IP rating of 67. So the first number shows that the sensor has a dust tide, so there's no ingress of dust. And with the second number, you can see that the sensor and the thermal camera is protected against temporary submersion in water. So here we have IP 67. It's also very important to take care about the ambient temperature. The thermal cameras can be normally used in ambient temperatures up to 50 degrees C. We have also a model which can be used up to 70 degrees C, that's the PI 450i camera. And yeah, for this, we need also a solution to cool down the thermal cameras. And also, I mentioned this before, the optics must keep clean. For this, we have the three solutions. We have here Cooling Jacket Advanced, where we can integrate our PI thermal cameras. And for our small camera series, the XI series, we can also integrate these series into the cooling jacket and with an integrated air purge. And for outdoor applications, so if we have applications outdoor where we have very harsh weather conditions, where we have hot and cold temperatures, we have created here a special outdoor protective housing.
Yeah, let's go into detail a bit. So the Cooling Jacket Advanced, so it's suitable for our PI series, as Mike mentioned. So that means it can be used for different kind of cameras, for long wavelength cameras, working in the 8 to 14 micrometer range using an uncooled bolometer. So those cameras can measure temperatures from -20 up to 900 degree, or optional also up to 1500 degree. But we can also put cameras, short wavelength cameras inside, working at 1 micrometer at 800 nanometer or even 500 nanometer spectral range, and they can measure then temperatures from 450 up to 1800 or even 2400 degrees Celsius. And also some of our pyrometers are fitting into this cooling jacket. So the specialty is this is made out of stainless steel. And yeah, you see it here. This is the extended version of this cooling jacket. So it's a double-walled stainless steel. So we have connections. If I turn it around, you see here for water, water in, water out, and also one fitting here for air, because we need also air purging, because if we cool down the whole housing, then of course there's a risk of condensation on the optics. So we need to put also some clean air to purge our lens. Yeah, it can be used up to 315 degrees Celsius. And we have also cables, Ethernet cables, and process cables for our output can be used up to 250 degrees Celsius. You see there is a certain gap between the cable maximum temperature and the maximum temperature for the whole, let's say, cooled camera system. And this can be, yeah, overtaken by some special cable cooling. But we figured out that the majority of applications is very happy with 250 degrees. So it's very seldom that people are using higher ambient temperatures. The whole housing has also an IP rating, IP65. And yeah, you see it here on this drawing. Also, we have an integrated air purge where we can keep the lens clean. Okay, let's go to the next part. Yeah, we have two versions, a standard housing and an extended version. And there is a kind of modular chassis for an easy exchange for maintenance purpose. And I can show you this on our live system here. So that means it's very easy. You can imagine this part here is fixed installed in your machine or in your plant. And of course, if you would like to do some maintenance, if it's necessary to clean the lens or to exchange some components, then it's very easy to take the whole chassis out, as I can show you here. So here you see this is our infrared camera, very compact size, which is connected via USB to this USB server. So the USB server is transforming then the signal into Ethernet. So we come out with a GigE cable. And we have also here installed our process interface, an extra PCB board, which allows us to have several analog outputs, alarm outputs, and also inputs to control the camera. And this whole setup is inside the cooling jacket. That means it will be cooled and can be used up to 315 degrees Celsius. And here you see one of our high temperature Ethernet cables. So this cable can withstand 250 degrees Celsius. And you see it's very easy if somebody needs to take some maintenance. So it's easy to take it out. And also here, again, to put everything in after the service, and everything is running. And the process can be controlled in addition. And also from outside, it is possible here on the front still to focus the lens. This is also very important detail. Yeah, and we have two versions. One is the standard version, as mentioned, and the extended version, what we have seen here, is able to carry also some additional components like this USB server I mentioned, or in the top picture, you see some very small and compact industrial PC, which is then also integrated in the cooling jacket and will be cooled. Yeah, we figured out in some applications, even our fantastic air purge, which we have integrated as part of the cooling jacket, is not sufficient. If it is very dirty or if you have very fine dust, like in a glass plant. Yeah? If you have a float glass applications, normally it's a very clean application, yeah, but you have some fine dust, and over time, this dust is somehow sticking on the lens or on the protective window. And we figured out it's better to have this kind of laminar airflow, which is running parallel to the lens or to the protective, to any kind of protective window. And therefore, we created this additional accessory for our cooling jacket. And I can show you this also live. Switch to the camera here. Yeah, so you see it here. So this is the laminar air perch, and it can be mounted easily in front of the cooling jacket. And you see it here, we have a protective window inside, and it's also very easy to open this. That means you can imagine the cooling jacket is mounted here, and you can easily fold this by 90-degree angle to clean the window or to make some adjustments, and then easily fold it back and fix it again with those two screws. The base plate of this air perch unit is also double walled. That means we have also connections here for water cooling. This is very important. I show you later in application examples where you can imagine that it is very important, because the heat always, or in a lot of cases, comes from the front, from the application side. So we need to cool this part. This is very important. Yeah, and the airflow direction is adjustable. Of course, in a lot of applications, we would like to have this laminar airflow running parallel to the lens. But sometimes we figured out, especially in the float glass applications, where we are looking, you see it on the left picture, where we are looking from the top down to the glass, which has temperatures between 600 degree or then lower and lower on the cooling section. But the heat from the process is going up and touching the unit. And therefore, we figured out in those kind of installations, it's better to use the airflow in direction, let's say downwards, to keep the process heat away from the lens or from the protective window. And this can easily be adjusted in this air perch. Yeah, you see here some application example, a waste incinerator, very rough conditions. So the camera with the cooling jacket, with the laminar air perch was installed on the door, on the wall. And you see we are looking inside an incinerator process, in combustion burning process. And so we used water in with 25 degree, water out was 38 degree. The temperature directly in front of the air perch was about 305 degree. And we could cool the camera down to about 50 degree. And we set also an alarm level for the camera, so that the operator gets an alarm if the cooling maybe is blocked or if he gets some problem.
Yeah, let's have a look to our small camera series, the XI camera series. And for this series, we have also 3 additional accessories. First, also the air perch laminar. And if we change the camera position, so we have here also an air perch laminar, which has also an included protective window. So the air will go here in and comes out on the top of the air perch. And yeah, you have the window to protect the lens and the camera. And we have also a water-cooled housing. This water-cooled housing can be used up in an ambient temperature up to 250 degrees C. We can show this also here on the table. So you can see our camera is integrated here into the water-cooled housing. This water-cooled housing has a water entrance and a water exit. And we have here also integrated our laminar air perch, where the air flows in here at this position. Additional, we have also a shutter available. The shutter helps to protect the lens at conditions. So if you have falling parts or you have particulars which are flowing through the air, these particulars can destroy the lens. And for this, we have here a special shutter. So if the camera is not in use, you can close the shutter to protect the lens every time. And if you use the camera, the shutter can open. And if you have falling down particulars or falling down elements on the lens, we can also close the shutter in a fast closing time. And this is a very fast movement. So if there are falling parts down to the lens, we can save the lens that we immediately close the shutter at this time. Yeah, you can have all elements as single parts. So you can have the air perch, the water cool housing, the shutter. And you can have also the combinations of all elements. So you can have the air purge together with the shutter, or the water cooling housing together with the shutter, or all three elements together, that you have always the same safe condition for your measurement task. Yeah, here we have an example where we can use the shutter, especially on the left side. You can see that the camera has a top position. So the camera is looking down on a process, on an application. And yeah, we can here close the shutter if the camera is not in use. So that means there's no need to have many maintenance intervals. If the camera is closed, the lens will be clean all the time. And on the second picture, you can see a glass tempering line. So glass is coming out of a furnace, and we are measuring the glass temperature, the surface temperature of the glass, which is coming out of the furnace by a line scan process. So our software can scan line by line, and finally you will have a complete infrared image. And during this process, we can open the camera immediately. So then we can do the measurement. You can see this on the picture below. And if this task is ready, if the glass has passed our camera and the measure is done, we can also close the camera immediately, so the camera is saved. And on the right side, you can see a situation if glass is broken. So it could be that during the glass tempering line process, glass breaks, then the glass can fall down on the lens. And for this, we can use the fast closing mode of the shutter, as you can see on the right image. If glass falls down, the shutter closes immediately, and that saves the camera every time. And we have every time a safe condition here.
Yeah, and we come to the next part, outdoor protection. So what means outdoor protection? It's protection from sun, rain, snow, dust, and any other environmental threats. And we have seen already, of course, we can cool our cameras, we can protect them in harsh industrial environments. But if it comes to outdoor use, then of course we have sometimes heavy sunshine, or we can have heavy rain, we can have snow in winter time. So that means we need to protect it. And for this purpose, we have this outdoor protective housing, which allows us to operate our images in a temperature range from -40° up to 50°, or also in a special version up to 60° for some of our images. And yeah, how are we doing this? We have a temperature controlled heater in this housing and a fan to circulate the air. And this housing, if it is closed, has also IP66 protection rate. And also here we have an air purge included, and maybe we can show this also in our top view. That means here we have the outdoor protective housing. If I turn it to the camera, then you see here we have our air purge. This is also a kind of laminar air purge, so that means we have the connection for the air here, and there's also a kind of air curtain which is generated to keep this protective window clean. And if I open the housing, then you see here is our camera installed. It could be our PIs, could be also here our XI camera. So it's really flexible for different kind of cameras, for short wavelengths, long wavelengths cameras. So can be used for all our imaging products. And also here you find again our USB server, which is then in case you have a camera with USB output generating an Ethernet signal. And yeah, below this USB server we have then our heater and our fan, and also our process interface. If you need some alarm outputs, fail-safe outputs, analog outputs, can also be integrated in this housing. Yeah, a protective window and a laminar air purge is included in this housing. Optional, there is a high definition video camera. So that means in some surveillance applications, fire safety applications, people are interested in having, in addition to the infrared image, also a visible image. So this can be done by this combination of a visible camera and infrared camera, everything in one housing. And also you see it here, the small hole in this air purge is then the visible camera. So it will also be purged by air. So that means also here the maintenance is quite long. This high definition video camera has 1280 × 720 pixel, works with 30 Hertz, and has 65 degree field of view. And the data of both of the infrared camera and of the visible camera is streamed via one Ethernet cable. So the whole installation effort, it's quite low, except it comes to, let's say, low temperature, where you need the fan and where you need the heater, then you need an extra power supply. If you just need a kind of protection housing for protecting it in normal conditions, let's say, then it's enough to have just the Ethernet cable and everything can be powered over Ethernet. Yeah, we are coming to the end, and you see, of course, you have seen in the presentation that we are using CAD systems. There were some slides or some small videos showing this kind of CAD simulation in 3D. This is, of course, good for our construction engineers, that they see what is the air doing, how is the airflow running in those air purges, or how is the circulation in our cooling systems. But if it comes to real applications, sometimes the proof of the reality is a bit different. We figured it out that even the best air purge system constructed fails or needs some optimizations. And for this purpose, we generated some test chambers in our company where we can at least simulate dirty environments by using, we are using a kind of clean powder, but we can distribute this powder. We can also generate different ambient temperatures in this chamber, so we can really see for a 24/7 use how is the long-term cleanliness of the window or of the lens, and how is our air purge working, and where do we need some optimizations. Yeah, I think we are at the end of our presentations, and I hope it was interesting. And if you have some questions, then please feel free to ask us.